Okay, so we left off on part A where it's asking for the points of inflection and the local max. We found that the point of inflection, Pi, was at x equals positive 4/3. And we found that the max, I'll put over here, the max was at x equals 3.189. The minimum was at negative x equals negative 0.523. Now, which I also answered on part A, but part B says find the intervals of increase and decrease. For intervals of increase and decrease, we've done that before, and you're going to graph the first derivative was a parabola, an upside down parabola that passes through negative 0.523 and 3.189. And it's an upside down parabola. So the intervals of increase and decrease, the intervals of increase will be from negative 0.523 to 3.189. And the intervals of decrease, so you would say f of x is decreasing from negative infinity to negative 0.523 and from 3.189 to positive infinity. So f of x is increasing, f of x is decreasing. So you've seen that before. We've done that plenty of times. Now for the second derivative, which was negative 6x plus 8, my point of inflection was at 4/3. When I graph this, it is a line that has a negative slope. It does pass through 4/3 because remember, when you solve that, that's the intercept, the x-intercept. It has a negative slope like this. And the second derivative, remember, describes concavity. When the second derivative is positive, it's concave up. So, and we're referring to f of x. F of x is concave up in negative infinity to 4/3. When the second derivative is negative, f of x is concave down. So f of x is concave down in the interval of from 4/3 to infinity. And that's part B. Part B is asking for the intervals of increase and decrease and the concavity, the intervals of concavity, concave up, concave down. Okay, let's look at part C. Part C, same problem, says identify the local max and minimum and global max and min. When we graph, and it's in the interval from negative 2.5 to 5, from negative 2.5 to 5. Okay, so when we graph f of x, it's a cubic. And in part A, we found that my local max, okay, my max was at 3.189, and my min was at x equals negative 0.523. So let's just say x equals 3.189. Okay, So we know that these maximums and minimums are what we call local max, local min. But I want to also find the global max and global min. So what we have to do is check the y values for each of these, as well as the y values for the endpoints. Because I have a closed interval, and this is the only reason why, because I have a closed interval of negative 2.5 to 5, I have to check what the y value is for those two x's. For the x, so I need to find what f of negative 2.5 is and what f of 5 is, and compare it to f of 3.189 and f of negative 0.523. Okay? The fastest way to do this is to check your calculator. So bring out your calculator. I'm going to put you on pause. Bring out calculator. Okay, so I've entered my equation into the calculator here. This will go a lot faster. Remember, my goal is to substitute f of 3.189 and f of negative 5.523, f of negative 2.5, f of 5, because I want to find out what these y values are so I can find the absolute maximum and the absolute minimum. Going back to my calculator, I'm going to substitute into y1, so exit the graphing screen. You don't even need to graph it. And go ahead and find those values. As you calculate those, I just went ahead and did it here. We find that the y values are as follows. Now, when you look at the y values, notice that f of negative 2.5 is the biggest y value from the 4. That is the global or absolute max, because out of the 4, that is the highest y value. That's going to be the highest the graph is in the interval from negative 2.5 to 5. And you're only doing this because they give you an interval. See, if this was if they didn't give you an interval, it would go from negative infinity to infinity, and the graph would not have an absolute max or min because it would go on forever. But because they do this, you have to check the endpoints. I'll show you what the graph could possibly look like. And so the absolute minimum would be this guy. The absolute minimum would be the negative 0.523. This is the absolute or global minimum. Now notice that it is also the local minimum, and that could happen. You could have the same exact value be both the local and the absolute. Okay, so now if the question says, if they ask what is the global or the absolute, I'm going to go with absolute from now on because I believe that's what they're using. What is the absolute max? If they say what, then they are referring to the y value. What is the absolute max? Then the answer would be 48.125 because they want to know what is the highest y value. Now, if they say when is the absolute max, then the answer would be x equals, or it would be at x equals negative 2.5 because that's where it's happening at that x value. So that's the difference between the two. Okay, so this is how it would look like. This is how it would look like graphically. from the interval negative 2.5 to 5. Notice that at negative 2.5, that is the highest the graph goes. So that is the absolute max. Whereas this hump over here, that would just be the local, or also called relative max. And if you look at the minimum, which is at the negative 0.523, that one is actually both the local and the global, because if you could barely tell, but this one here, this one at 5 is not the lowest one. It's at negative 0.523, whereas the lowest out of the entire graph, that's the lowest point, the absolute lowest point, as well as the relative minimum. So negative 0.523 is where we have the absolute and the local minimum. Okay? Okay, practice the problems that I left for you, and hopefully you guys understand this. I'll have another video for you tomorrow. Thank you. Have a good day.